Hi, hello students. Let's start our discussion regarding the solid state only. Today, students, I'm going to I'm going to give you the introduction regarding solid state. First of all, you have to know what is the solids, and in this chapter, I'm going to discuss about the how particles are arranged, what makes difference between the one solid to another solid. I'll give some small examples. Then you can see the different kind of marbles are used in daily life. Some will be strong, some will be very weak. Sometimes you can see the different type of stones are there. Some stones are generally, where granite is there, generally used for making marbles. But all solids are cannot suitable for making a marbles only, like whatever maybe it is. So what I mean, the different kind of materials are there in our daily life. So what is makes them difference? I'm going to discuss about the solid state, especially about the solids only. So before I'm going to discuss about solid state, first I want to give the introduction regarding the matter. Look at here, this concern one point is matter is anything that has mass and takes up space only. I want to say very clearly, very well, matter means anything which occupies space, it has mass and volume is called matter. So whatever the material, if you see the universe, it has certain things are there. The composition will be there. In this chapter, I'm going to find the total volume of the particles arranged. For just imagine here, this screen is there now. One just consider one screen is there, one cube. In this cube, how many particles I can arrange? So I'm going to discuss in detail only. So this chapter is very interesting, and then I'm going for the classification of matter. Do you know, students, here we classified the matter based on the physical state into solids, liquids, gas, plasma, or Einstein. You have wondered that when you study about the solids, liquid, gases, do you know very well the properties of the solids, liquid, gas? In 11th standard we study about the gases, and 12th standard we study about the liquids and solids also. So very well is then here one part remember, along with solid, liquid, gases, two more states will be available. That's called plasma and Bose-Einstein Fermi condensate also will be available. Total 3 states available: plasma, Bose-Einstein condensate, Fermi condensate. Quark also is the quark and condensate also is there. Regarding these 4 state of matter, I am not discussing in detail. So I am saying very clearly, I am focusing about only solid state only. Before I am going to focus about solid state, first you have to know the difference of the solids. What is the solids? What makes the changes of? I said very clearly, solid, liquid, gas are interconvertible. These state of matter can be interconvert into one state of matter, another state of matter, by changing of the 2 factors: temperature, pressure, very well. If you take ice cubes, I can convert ice into liquid, liquid into vapor also. So remember here the first important thing is then discuss very important slide is the stability of the state of matter. So what happens, I'm saying very clearly, whether the matter is available in the form of solid, liquid, gas only. 2 factors play a crucial role. The 2 factors, one is the intermolecular force of attraction. This is very interesting part. What is intermolecular force of attraction? The force of attraction which hold the atoms or molecules together. Intermolecular force of attraction decides the physical state of the matter, whether the matter is solid, liquid, gases. In solid, strong intermolecular force of attraction is there, less intermolecular space will be there. In liquid is there, now when compared with the solid, high intermolecular space will be there, less intermolecular force of attraction will be there. When you come to gas, when compared with the liquids and solid, high intermolecular spaces will be there, less intermolecular force of attraction. So we got very clear, based on the force of attraction, we have been classified into the solids, liquids, gas. So what I mean there, what atoms are usually considered in intermolecules? Here the particles may be atoms, molecules, ions. So we say atoms is there, you consider the atoms also possible, molecules also possible. Look at ions also possible. Ions means sodium chloride, NaCl crystal, not sodium chloride, KCl, MgCl, whatever maybe salts are there. Molecules are solid is there, graphite will be there, diamond will be there, Buckminster fullerene will be there. Atoms also will be there, metals will be there. So in this chapter, I'm going to discuss about how atoms are arranged in the solids. Next important one, thermal energy. Thermal energy is proportional to the absolute temperature. What means here that when the solid is liquid, gas, whatever the physical state is available, based on its thermal energy. Whenever any state of matter having the low thermal energy, it is solid. High thermal energy means gas only. Okay, Thermal energy decides the physical states of the matter. Then students, one more slide is here. You get very clear idea. This is very important slide, students. Here, just consider that this is solid state of matter. When I take the solid, what happens? The atoms, the particles, whatever is there, they are properly arranged. A regular arrangement of particles we can able to see very clear only. You can see the regular arrangement particles also, and also we can see the many surfaces. This one surface area, here one surface area, upper one surface area, back side also is there, down also is there. So what I mean, the many surface areas for solids only. And also you can see the proper arrangement will be there, strong intermolecular force of attraction will be there. We can see the general solids are long range order they are called. Why the long range order? You can see here this line is same only, this line is same only. And also you can see where the general crystalline solid has sharp edges will be there. One more point is that here you consider the liquids what happen irregular is there, particles are irregular arranged also. Gases more irregular will be there. So what happens, increase the temperature, increase the kinetic energy, solid state of matter can be converted into gaseous state. So what happens, by changing of the temperature and pressure, one state of matter can be converted into another state of matter. So these are the basic ideas, students. Let's have today I'm going to discuss about especially only solids only. So first of all is what is the properties of solids only. First point is then solids have fixed composition and fixed shape will be there, mass will be there, volume will be there, and high density also will be there. So what I'm saying once clearly, solids have fixed composition will be there, fixed mass will be there, volume will be there, and shape will be there, and high density also will be there. And what about the argon? Consider we can compare density of the liquid, gases, and solid having high density. One exception will be there. If you know solid, you say no, ice molecule is floats on the water, water have high density. One exception will be there. One more point is in solid, intermolecular force of attraction very strong, intermolecular space will be there now, okay, very less only. Intermolecular space, that reason why you can see the proper shape for the solids only. And most important points for solids here, just consider the solids have different mass will be there, volume will be there, shape will be there. Solids are compact structure, very important. What is compact structure means? A regular arrangement, regular repeating units are present only. Whenever these are regular repeating units are there, now let's say just consider the solids as a proper only. Next one is then they have the strong interparticular force of attraction. In the solids, the particles are very strongly bounded. That's the reason why they are available in the proper shape only. The particles in a solid oscillate from the mean position. Do you know variable is how heart is beating is then you cannot see, but it is working. Similar way, when the particles are, what are the particles are present in the solid, startly always undergo motion only. Oscillation, maybe rotational motion, vibration, translation motion, whatever maybe there, they will be oscillated only. Solids are rigid, incompressible, because they cannot be flow only. Generally the solids doesn't have any fluidity nature is there, so it cannot be flow only. Next very important point, solids have many surfaces. Solids have many surfaces. In this chapter I am going more focus about the surface of the solid only. For suppose if I say like that, you will get small confusion. You can see the one cubic, Rubik, you can see Rubik. What happens here, just consider this one is the crystalline cell, crystal lattice only. In this crystal lattice, just consider take solid only. We can see the many faces are there. Many faces are there. And say consider how many faces will be there? 1, 2, 3, 3 this side, 3 be outside. Total 6 faces will be there. 1, 2, 3. Bottom is the 4, back 5. Here 6 only, total 6 faces will be there. How many edges will be there? Look at the edges are there. 1, 2, 3, 4, 5, 6, 7. Back side 1 is 8. So there is 8 edges. Okay, 8 edges will be there. How many faces will be there? General consider 6 faces will come. 1, 2, 3, 4, 5, 6 faces will come. 8 edges will come. And also one more point is then the solid. Just consider the, I said very clearly, solids are long range order. Long range order means you can see very properly regular arrangement of the particles. You can be very clear on it. So what I mean, just consider here the particles are there. This is called lattice points only. Here lattice points only. Here what happens, one lattice point join together, they make a one small cube is like this one. This is called unit cell. What is meant by unit cell means the smallest repeating unit present in the crystal lattice. The smallest repeating unit present in the crystal lattice is called a unit cell only. So what happens, you can see the one cube is there like this only, many cubes are joined together, they make a big one. This is called unit cell only. The smallest repeating unit present in the crystal lattice. Students, you can remember here one more point, you can see very clear is there no here. This is called unit cell only. This is called lattice point. It's called edges. You can see no, this is called edge only. This is called face. Here one face will be the back side here. Here also will be, here also face will be there. 6 face will come. How many edges are there? You can see very clear. 1, 2, 3, 4, 5. 5, 6 will be there. And down also will be there. 7 and 8 will come. 8 edges will come only. Next one important thing is that here this students up to discuss about the basic idea regarding this one is I want to discuss very important point is there now. In this one I'm going to discuss about the classification of solids. Up to we didn't discuss about classification of solid. Here I'm going to discuss about especially about the classification of solid only. First of all, in this chapter I'm going to more focus about the types of solid. Crystalline solid, amorphous solid, what are the particles arranged, generally based on the molecular force of attraction, covalent solid, ionic solid, metallic solid, crystal lattice, everything I'm going to discuss right on. Types of structure adaptive solids. Solids are different structures will be there. Just consider the cubic structure, orthorhombic, monoclinic. You can face center, body center, edge center, like the many will come. Imperfection solids. Solids are not perfect, so there is some imperfection will be there. I'm going to discuss in detail regarding the imperfection of the solids, defects in the solids also. First of all, first one slide is coming. Look at here. This consider the classification of solids only. Students, you know very well, based on the arrangement of the particles. Based on the arrangement of particles, solid has been classified into 2 types. Crystalline solid, amorphous. Amorphous stands for powder. No form, no regular arrangement. Crystalline solids. Okay, Greek word crystalline solid where regular repeating units are present. A proper arrangement of the particles are present in the crystalline solid only. Amorphous solid, no proper structure. Example for amorphous solid is rubber, glass, plastic. Students, one point I want very clearly, when you place a glass in down, what happens? Glass becomes small pieces. We cannot see the only one kind of structure arrangement in that pieces only. But you can take the sugar crystals are there, no? They generally have the regular shape, the proper structure will come. So I'm going to in detail on the crystalline solid and amorphous solid also. General solids has been classified in 2 types. Crystalline solid, amorphous solid. We can see very clearly in the crystalline solid is long range order. We can see the crystalline solid long range order means no, we can see proper arrangement will be there. The red color atoms are present here. Here blue color atoms are there. Again red color atoms are there. You can see on the line itself is there. You can level this line also. You can whatever line. But when you go for the amorphous solid open, there is no proper arrangement is there. Irregular will be there. So amorphous solids are general. They have the short range order. Amorphous solids have short range order. Crystalline solids are long range order only. So long range means you can see the any point is there, no, the proper arrangement will be possible. Next one is types of solid. Crystalline solids, well ordered, definite arrangement of the molecules, atoms, ions only. Proper arrangement possible. Crystalline solid have an order, repeating structural units only. What happens is consider crystalline solid, the proper repeating structure will be there. Look at the repeating structure. This consider this one structure repeating, this one is repeating, this one is repeating. Repeating structure is possible. Then crystalline solid have a sharp melting point will be there. Crystalline solids are anisotropic. It's very important. What I mean anisotropic means, no, when you observe the physical properties like refractive index, thermal conductivity, it varies from the one direction to another direction. So what happened there? This is called anisotropic only. Anisotropic. So how you are saying the anisotropic means? I will give you an example. You get very clearly. Look at it. Just consider. If I just observe the refractive index through this line, only a kind of atoms are there. It will be get different only. If you observe the properties in this direction, I can see the AB kind will be there. So what happened there? Because look, you can see very clearly. So general crystalline solids are long range order. Repeating structure is present only. AB like that repeating possible. So what happened there? General anisotropic means if you observe the physical property, refractive index, thermal conductivity, it varies from the one direction to another direction only. So this is called the general idea of the crystalline solids only. One more point is coming to the generally crystalline solids are true solids only. Crystalline solids are true solids, they will call only. One more point, just consider the simple one is there here. Just imagine the crystalline solids have the long range order. Amorphous solids have the short range order only. One more thing will get very clear, and you can say very crystalline solid proper arrangement will be there. Amorphous solid improper arrangement will be there. Coming to the more properties of crystalline solids, they have the sharp melting point, definite heat of fusion only. Crystalline solids are anisotropic. Crystalline solids have isomorphous. Isomorphous means you can see the different crystals have same like arrangement. Sodium chloride, magnesium oxide is atomic ratio is 1:1. Sodium nitrate, calcium carbonate 1:1:3 will come. You can say 1:1:3. 1:1:3. Potassium sulfate, potassium chelate is then you can see very clearly the number of atoms in a crystals remaining constant. This is called as a amorphous, just isomorphous, not amorphous, isomorphous. And more points of crystalline solids, here remember just crystalline solids are the polymorphous only. What is polymorphous is very important is a single substances crystalline is two or more forms. What happens is single type of atoms are there, crystalline solids, different structures are possible at different temperature. You can see very clearly diamond and graphite is there, both are crystalline solids only. But graphite is soft only, diamond will be strong. The diamond have a lustrous nature, graphite doesn't have a lustrous nature. So what I mean, both particles are because of different arrangement only. So this called as a crystalline solids are polymorphous, different main forms will be available. Okay, next coming to here, the one more point is that here just consider crystalline solid generally they have sharp melting point for definite heat of fusion also. Crystalline solids are anisotropic nature. Anisotropic means I said very clearly different physical and chemical properties around the different direction. Isomorphous. What is isomorphous means? Different crystals have the same ratio of the atoms. Polymorphous. Polymorphous, what when you consider the very well we discuss about the rhombic sulfur, monoclinic sulfur. Both are sulfur, one is crystalline form, one is different form only. This based on the different arrangement of the particles only. So next coming to the we'll go for next move on to the amorphous solid. Very important. Amorphous solid means no definite arrangement of the molecule will be there. Irregular will be there. We cannot see the only one kind of the arrangement will be possible only, not possible only. Consider if you want any confusion and crystalline solids in the school how you are sitting in the benches. Amorphous means in the break how you are sitting on. Next one is amorphous solids where generally vary in the melting point, boiling point. Generally amorphous solids have a long range. There is no fixed melting point, boiling point one. Amorphous solids are isomorphous. If you observe the physical properties, whatever maybe is there, you can see the if you observe physical property, any direction remaining same only because irregular arrangement of the particles. Okay, one more point is there here. One more point consider the general things are called as a not a true solid. It's also called a supercooled solid only. Amorphous solids also called as a supercooled solids only. Why they are called supercooled solids means before I'm going to discuss a little more point regarding the amorphous solid only. Generally, the first point is the constant particles are arranged in a disorder. You can see in the amorphous solid whatever the particles arranged then is irregular. There is no proper arrangement. They exhibit only short range order. They are exhibiting only short range order. There is no long range order. They doesn't have any sharp melting point, boiling point. There doesn't have any sharp melting point or range melting point, boiling point. They exist in the isotropic. Isotropic proper only one type of structure. Glass. On increase in temperature, amorphous solid generally becomes softer and become to melt. So what I mean when just imagine here when heat the water here just consider that it becomes liquid state. Okay, just consider see next slide is very important slide. The students say that this is very important. Why glass is considered as supercooled solid? Supercooled solid liquid only can call solid also. Answer that glass is just consider I'm taking this is wall. I place one gas for long years only. What happens at the bottom you can see the glass becomes somewhat thicker, not thinner, thicker. Why? Because means here just consider glass is an amorphous solid like a liquid. It has a tendency to flow. Even though you look like solid does start flow only for long time only. Through very slowly. This can be seen from the glasses of glass pans of the windows only or doors. Very old buildings we go for nothing. They go for what happens just consider that the bottom there is a very thicker, very long, heavy size of the glass. Why this happens is because of flowing nature only. Generally, just consider they are called as a super cool liquids. Glass also called as a super cool liquids only. And next one is final one is difference between the amorphous crystalline solid and crystalline solid. Amorphous crystalline solid. First one, you can just consider the amorphous solid means without form, no regular arrangement of the particles are possible. Or lack of, just consider the solids which are lack of the regular arrangement of the atoms or molecules, hence they are short range atoms. Just consider, you can see very clearly A, B, C, A, B, B, just consider A, B, C, B. Okay, just consider B, A, C, like the irregular arrangement will be there. When you come to crystalline solids are on which three there is a regular repeating pattern structures. Regular repeating pattern. It's very, very important. Now, what happens, just consider the, and also long range atoms. You can see very clearly A, B, C, again A, B, C, again A, B, C. Look at the proper arrangement will be there. What happens, because of this arrangement, what happens, the crystalline solid have a sharp melting point, boiling point. Amorphous solid doesn't have any sharp melting point and boiling point. Amorphous solid isotropic. Physical properties same at different direction. But crystalline solids are anisotropic. It means physical properties are different at different directions. Example, diamond, salt, ice, methanol, sodium, chlorine, maybe they have observed the physical properties at different direction, different value will get. That's called anisotropic. So students, up to this one discuss about the solid classification of solids, amorphous solid and crystalline solid.